In this video, I'm going to show you how to find the inverse of a function and also how to verify that two functions are inverses of each other. So here we have function f, and we want to find f inverse and also show that the function you found is indeed the inverse. Okay, so I'm going to replace f of x with y, right? We want to think of f of x as y. So y is equal to 3x plus 2. Now the inverse is really just when you swap the x and the y values. So put the x there, put the y there, and this is what we have. And we want to rewrite this and solve for y. Now, why exactly do you do this? I'm not going to explain that in this video because this is a crunch time video just for preparing for a test or something. I'll leave a link in the description for a more detailed reasoning as to why we do this stuff. All right. So for now, let's just solve it in terms. Let's just solve this for y in terms of x. Whoops. So that's not what we do. That's not the first step. Let's minus 2 on both sides because we want to get that y by itself. So this is x minus 2 is equal to 3y. How do we get rid of that y? Well, the y is being, I'm sorry, how do you get rid of 3? The 3 is being multiplied by the y, so undo that multiplication by dividing. So we get y is equal to x minus 2 over 3. And this is really the inverse function. So f inverse of x is equal to x minus 2 over 3. Now, how do we verify that this is, in fact, the inverse? Well, this is what you do. You compose both functions. You take f of g of x, and you should get x. But then also you should take g of f of x and you should also get x, right? So you have to do both of them. So let's verify it using the first way. So f, now this is f inverse. This is really what we're looking at is g of x here. So f of f inverse of x, let's see what that looks like. So that's really f of, well, f inverse is x minus 2 over 3. So what does that mean? That means wherever I see an x in function f, wherever I see an x, I'm going to replace it with x minus 2. And I have another video showing you how to compose functions, but you're basically seeing it right here as well. So this is really 3 times wherever I see an x, so there's an x right here. I'm going to replace it with x minus 2 over 3. So x minus 2 over 3 plus 2. Where did that plus 2 come from? Well, it's just this plus 2 right here. And okay, let's see what happens. Well, this 3 and that 3 cancel out, right? Because this is really just 3 over 1. 3 divided by 3 is just 1. You could only do that because this is all multiplication here. So we end up with x minus 2 plus 2. These two, this negative 2 and that positive 2, they zero out. And you end up with just x, right? So this one checks out. Let's do it the other way now. So let's do f inverse, because remember, that's really my g in according to this little formula. So f inverse of f of x, and let's see. So f of x is, what is f of x? It is 3x plus 2, right? Now, in the inverse function, I'm going to replace the x with this thing. So in this inverse function, wherever I see an x, I'm replacing it with 3x plus 2. So this is 3x plus 2 minus 2, right? This 3x plus 2 is really this right here. I could put it in parentheses, but because there's no multiplication or anything happening here, I think it's fine that we could just leave it like that. And it's over 3. Now, this becomes 0 right here. Right, that zeroes out. And this 3 divided by 3 is 1. So that cancels out. Canceling is the wrong term. It divides out into 1. And you remain with just x. And as you can see, it is a function. They are inverses of each other. So I just verified it.